All right, here we go. So least squares regression. So let's first of all take a look at what we have. And this data, by the way, this was real data. I did a thing a couple years ago. We had an extra day for some reason. I don't remember what it was. Maybe it was a half day, landed just perfectly. But I looked up data for the Big Ten conference. Okay, 14 teams in the Big Ten. No one knows why, but that's what they, it makes no sense, but okay. But what I had done was I looked up a whole bunch of data, like rushing yards, passing yards, how many wins did they have, how many overtime, all sorts of data on the Big Ten teams that year. And we went down to the computer lab, and everyone was using Minitab, and they were doing linear regression, trying to pair up a whole bunch of different things until they found the ones that seem to have the highest association. Now, based on what I just said, we can't automatically assume cause and effect, but at the time, we found the strongest correlation that the number of wins seemed to be related to the number of rushing yards per game. Now, again, is that always true? Not necessarily. Maybe there was no cause and effect here anyways. Maybe it's true in the Big Ten, but not other conferences. Maybe it was true in 2017, but not other seasons, whatever. But that's where this data came from. So I don't remember which team is which now, but whatever. So we made a scatter plot of this, and I want you to notice how Minitab makes the scatter plot. We have the response variable here is wins. The explanatory variable was rushing yards per game. And how those are labeled, by the way, is just however I enter, how I named my columns, okay, in Minitab. But what it doesn't show here, I think I cropped it off, is how Minitab will often name this. It will always say things like wins versus rushing yards per game. So even if they don't have these labeled on a graph, they, meaning College Board or anyone, if you have a scatter plot and it's named like this, you should always know that it's Y versus X. That's a standard protocol. I also want you to notice how Minitab shows the regression line. It doesn't use variables. It doesn't say Y equals. It literally uses the word. It starts with the y-intercept, and then it's the slope, and then multiplied by your explanatory variable. Do you guys remember last year that when we did y equals mx plus b, I told you one time that I like to reverse it? I like to do the y-intercept first. Okay, A, I think it makes more sense. And B, as an AP stat teacher, I know that's how it's done in statistics. You start with the y-intercept. I also am going to point out this y-intercept is negative 2.98, so about negative 3. Does that line look like it's touching at negative 3? No, doesn't it look like it's going to go towards positive 3? Okay, look at the x-axis scale. If that x-axis scale went back to 0, can you picture where that line, if it kept going, that it would be crossing down at negative 3? Okay, so you got to trust the math on this. Okay, so that you're not going to see the whole graph. You might only see that window. Back to that extrapolation thing we talked about yesterday. We only look at that particular window of data. Okay, but pay attention to the positives and negatives up here. All right, so you guys know what a line of best fit is. What we need to talk about is this thing called a residual. So for every ordered pair, where the line of best fit comes from, it's officially called the method. This is the least squares regression line. And I'm kind of jumping up ahead a little bit. Where this comes in, because when you were in middle school and you first made scatter plots, did you ever just like eyeball where the line went? You just like threw it and you're like, I'm gonna write in there, and you pull out your ruler and you make it look all pretty. Okay, there's more to it than that. Because actually this method, what you have to picture is every dot is either above or below the trend line. Some of them are pretty close to being on the trend line. But what you have to picture is if you dropped a perpendicular, or if you brought up a perpendicular. So every point you draw a perpendicular till it touches the trend line. Whatever this distance is, you create a square out of that length, and you calculate the area of that square. You draw a square Okay, so there are 14 ordered pairs on this graph. So you know how many squares I'd have to draw? 14. It's called the method of least squares because what it's doing is that line is being drawn so that when you calculate all these areas of all these squares, it's the smallest number possible. Now think about that. Think about how much math is going on in the background. When that trend line your calculator just draws it right in, it is drawing it in at the point where mathematically all of these squares are as small as possible. It's pretty impressive, okay? It's pretty impressive. Now, each one of these distances is called a residual, okay? Every time you draw one of these distances, that's called a residual, okay? Residuals, there is a formula for a residual. It's the difference between an observed or actual value. There's a formula for it. And this symbol, by the way, is literally read as y hat. I'm not making that up. Okay, so the formula is y minus y hat. Now, what y hat stands for is your predicted value. Remember, a trend line is used to make predictions. So basically, if you look at this trend line, you would say that I would predict that if a team in the Big Ten in the 2017 season, if they had 200 rushing yards, I would expect them to win about 9 games. Okay? The issue is not many of the points are right on the line, so my predictions weren't all perfect. So fact is, I'll use this team right here. They had about 145 rushing yards. Which one of these is about 145? Maybe this guy, maybe the 140. Yeah, I think that's him. Okay, so you had 147.1 rushing yards and you had only 4 wins. That was an underestimate. Okay, or excuse me, this is an overestimate because the estimated value, if you had 147.1 rushing yards, I would have expected you to have almost 6 wins. Okay, so the trend line provided an overestimate compared to what he really got, what he really had. The residual in this case is going to be negative because when you do the actual y value minus the predicted y value, the dot is underneath the line. So it's going to be a negative residual, but a negative residual means the line is an overestimate. And people get that backwards all the time. They think about a negative residual and they think underestimate. But no, if it's a negative residual, it means the actual y value was down here and the prediction was way up here. So the prediction was over. Compare that to this guy right here, this team. Okay, this team looks like about 220 rushing yards. So who's that? This one right here. So based on that many rushing yards, I would have expected only about 10 wins. You had 12 wins. Okay, so the prediction was an underestimate, but their residual will be positive because their y minus their y hat is now going to be positive. You need to know this formula. Literally, there have been questions on the AP exam that all you have to do is calculate a residual. You just have to know that it's the given y value minus the predicted y value. But you know how many people get it backwards? And so if the answer is supposed to be -9, they get +9 or vice versa. And I guarantee on a multiple choice, they'll both be options. Okay, you need to know it's always the actual y value from the data set minus the prediction from the trend line. All right, so this whole method is called the method of least squares. It was developed by a Frenchman named Adrien Marie Legendre. So these 3 formulas, you may need these. Okay, these are on your formula page. Okay, there's the R value that we just talked about. That's the formula for your mean. Nobody ever looks that up on their formula page. Do you have to look up the mean? No. That's your standard deviation formula. We don't usually look that up either. We just use our calculator. Even this one, we don't always look it up. We use our calculator. These three, you might need. Well, even this one. All this is it's showing you the format. Okay, you guys are used to y equals mx plus b. Well, first of all, reverse that. Y equals b plus mx. And then what they do is they switch the letters to confuse you. Okay, so instead of b being the y-intercept, b is now, yeah, and b becomes your slope. They literally switch up the letters on you. And by the way, look in your calculators. They're both in there too. Have you noticed that there's two linear regressions in a lot of your calculators? They give you the same answer, but one of them will give you algebra, mx plus b, and one of them will give you statistics, a plus bx. They give you the exact same answer, but it depends. You want to see it from an algebra perspective or a stat perspective, okay? So watch this though, because you also have a formula how to calculate your slope. Your slope will always be your R value times the quotient of your two standard deviations, which is kind of amazing. And then they give you this, which basically all they're saying is if you take a linear equation, your ordered pair x bar comma y bar should always fit your equation. We talked about that yesterday, okay? All right, that's where I'll stop. And tomorrow Thursday, we will pick up and we're going to go through an example of what you should know how to do.
Oh, I didn't really like Major League Baseball.